I'd like to introduce you to the Electronics Experiment Kit. We use this kit in the World of Electricity and Electronics course, also known as ELTEC 208. This kit is available at the Pirates bookstore, and we'll use this kit during most of our lessons for hands-on experiments with electronic components and parts. The first thing I'd like to show you is the protoboard. Protoboard is what we'll use to construct our electronic parts. Protoboard is a plastic device which has holes in it and has places for mounting electronic components that you can do without any soldering or any other kind of permanent wiring. It makes it very easy to build and test electronic circuits. And it uses behind the plastic there are springs that make connections with the wires. Here's a protoboard that comes with your kit, and I've got some wires installed there and a couple electronic components. And in our first hands-on lab, I will show you how to use the protoboard in greater detail. Now the next thing I want to show you is there's a circuit built on the protoboard with components, and you can see how they mount on there. Actually, that's a slightly smaller one than the one that comes in your kit. It's the same type of a protoboard. And then also included in your kit is a power supply. The power supply mounts onto the protoboard so that you can make connections to the electrical power source, and you can connect a battery or a wall power supply transformer to the power supply, and that way you can then power your experiments. So the power supply is a very nice thing to have because it lets you save on batteries. You don't have to buy batteries for every experiment. So here's a power supply that comes with your kit. Also, you have jumper wires in your kit. The jumper wires are used for making connections, and these nice little jumper wires very convenient because they are multiple colors and different lengths, and they're very easy to push into the board. Quite a great improvement over just plain wires that we've used previously for experiments. So that's kind of nice. So you have quite a bundle of wires that come in your kit. Here's a bunch of wires that you can use. So that makes it nice. Okay, next thing you have is some resistors. Resistors are electronic devices that provide resistance. That's electrical friction that controls the flow of current. Resistance, without resistance, electricity flows unhindered and flows quickly through a wire at high current. With a resistor, you can control the current. Resistors come in varying values of resistance, measured in ohms, and so there's a color code on each resistor, and that color code is something we'll learn how to read. So there's quite a selection of resistors in your kit. There's a list of them here, and there's quite a bunch of them in the package, and they're all color coded, so we'll need to learn the color codes to read, to be able to use those, to find them. And why, you might ask, are there so many different resistors? Well, sometimes you need a large amount of resistance to decrease the current, the flow of electricity, to a very small amount. Other times you need a small amount of resistance to allow a large amount of current. So there are varying values here for various amounts of current, and we'll use a good number of these different resistors. And actually I wanted to include in the kit a nice assortment of resistance values that are typically used for experiments. So there's even some here that you'll find useful later in your kit. And there's a picture of some more resistors of various sizes. The ones in our kit are called 1/4 watt resistors. That means that they can handle 1/4 watt of heat before and safely handle that. If they get a great deal more than that, they overheat and burn up. So that's called the wattage. But they do make resistors in all kinds of different wattage values, so that if you have to handle larger amounts of power, that's a consideration. That's something you always need to give some thought to when you're building an electronic circuit, is to make sure that the amount of power handling capability of a resistor, or any other component for that matter, is sufficient to handle the amount of power that will be required, which is in the form of heat. As I mentioned, the resistors have a resistor color code, and in one of our lessons I'll go into great detail about how to read that color code. Basically it's a type of scientific number or exponent value that has two color bands representing the first two digits of a resistance, followed by the number of zeros or the multiplier. So we'll talk about that in greater detail when we get into the lesson on resistances. And also when we build each project, I'll review this quite a number of times. Another kind of component you have in your electronics kit are some potentiometers. Potentiometers are adjustable resistors or variable resistors, and they allow you to vary the resistance by turning a knob or adjusting a small screw. So you have 3 of those in your kit at least. Here's the one that you have in your kit. There's a couple different values for this one. There's also there may be also a different style in your kit as well. For example, there might be one of these type here, which has a screw adjustment on the top for resistance. So they do come in different styles. The way a variable resistor works is it has some type of knob or screw that you turn, and that adjusts a wiper that moves around and makes contact with the actual resistive element, or strip, which is a material that provides the resistance. So it's like a regular fixed, the other kind of resistor that I showed you before is a fixed resistor. This is an adjustable resistor or potentiometer. Another electronic component you have in your kit is the capacitor. Capacitor is a device that stores electric charge. A capacitor is able to hold electricity, a small amount of electric charge, kind of like a battery, except unlike a battery, it doesn't necessarily involve any chemical reactions. There is a kind of capacitor called an electrolytic capacitor that does have a chemical in it called the electrolyte. But unlike a battery, there's no chemical reaction wherein it works on a metal that is dissolved like in a battery. So it's not a chemical device as such. But basically a capacitor is a device that has 2 metal plates. One metal plate is charged up, positive, and the other charged negatively. And those 2 plates are close to each other, and there's an insulator, or what they call dielectric, between the plates. And many times that takes the form of aluminum foil with some kind of plastic or paper insulation between the layers of the aluminum foil. So your kit has several different kinds of capacitors in it, and quite a variety of different values or capacities. The capacitances are measured in farads, and I've included a list of the different components and their values, and you can see inside the bag different sizes in there. One of the reasons I suggest getting a magnifying glass, by the way, is that these types of things are often very small, and the numbers printed on them are very small, and if you're like me, you need a magnifying glass to read them. Another component you have are light emitting diodes, or LEDs, and come in a variety of different colors. So light emitting diodes are used as a type of light, like a light bulb. In fact, you could use light bulbs for lights in electronic circuits, but LEDs are extremely durable and rugged, and they don't use much electricity to produce the light. They're quite efficient, so they become extremely popular for electronic circuits and devices. And here's our bag of LEDs. They come in different colors. And so there's even one in your kit that is called there's one that's RGB, that's red, green, blue. It changes colors, kind of neat one. And there's a white one, a blue one, a green one, a yellow one, and a red one. Or there's actually several of some of these, so there's multiple LEDs in there. Another component you have is a 7-segment light emitting diode display, or LED display. It's a numerical display, and you can light up the segments to form numbers. So what you would do is connect up some type of circuit to it, and then by activating the proper LEDs, you can form all the different numbers from 0 through 9 on one of these displays. Here's a one that comes in your kit. So light emitting diode, 7-segment. It's called 7 segments because it's made out of 7 rectangular LEDs that form the different numbers. Another thing you have in your kit are some diodes. Diodes are one-way electrical valves. They only allow electricity to flow in one direction. And there are actually a number of different kinds of diodes we'll learn about. They have special purposes. Almost all of them have that characteristic that they allow electricity to flow in only one direction. Also, there's some transistors. Transistors have 3 wires, 3 connections, and they are made out of the same materials diodes are, but the transistors allow you to control the flow of electricity using one voltage or current to control another current. And so your kit has a variety of both diodes and transistors inside it. And so here's the kit, and there's a list of both the diodes and transistors in the kit. And there's also some integrated circuits. Integrated circuits are also known as chips, or ICs. And they are devices that contain a number of electronic components that do various functions already put together for you. And those components might be resistors, transistors, diodes, capacitors, all put inside of a package ready to be used. And so I put a number of integrated circuits in your kit that are included in there, and they are also listed on the list that comes in the kit. In your kit there's also a transformer. A transformer is a device that uses coils of wire and an iron core to allow you to transfer a signal, an alternating current signal. That's an electrical signal that has electric currents that flow back and forth, to transfer and convert from what's known as impedance to another. They're also used to raise and lower voltages, alternating current voltages. So these devices always run on alternating current of some kind, or pulsating current. It cannot run on just straight DC or direct current. Otherwise they don't function. But They're used a lot in electronic circuits for coupling electronic circuits to power supplies, to sources of alternating current. For example, you could use them to lower the voltage going into your electronic circuit from the wall outlet from 120 volts, say, to 12 volts, something like that. They're also often used for coupling electronic circuits to speakers and things of that sort. Here's the transformer that comes in your kit. This is an audio, called an audio transformer. So it's not a power transformer. It's for small. It could be used for a small amount of power, but generally it's used for audio, for driving speakers. Another component that's in your kit is a relay. A relay is an electrically operated switch. It's an electromechanical device. It means it has both mechanical and electrical components inside of it. It is actually has moving parts inside of it. Sometimes the cases are see-through and sometimes you cannot see through them, but they're pretty much all built the same. The one that's in the picture there, you can see a coil of wire. That's actually an electromagnet that turns on and off. And with that, you can activate the switch inside the relay. So here's our relay that comes in the kit. Typically they look like this. These are designed to run on DC, direct current, into the coil. So 5 volts is what this one operates on. So, and that's what that little power supply also produces, is 5 volts. Oops. And that pretty much wraps up. Oh, there is a couple more components here that I can show you. Just a couple more. Yes. Here in this bag there is a speaker. So the speaker is for making audio, for sound. We'll use that. So that would work. That would work with the transformer. In fact, that would be something that would work together. Transformer and the speaker. Speakers can also sometimes be driven directly by electronic circuits, but by using a transformer, it often makes it more efficient and allows the electronic circuit to make the speaker drive at a higher volume, make it louder. So you find transformers a lot in radios and televisions, things like that, stereo systems. There's also in your kit a number of various switches, little switches that go on the breadboards. There's some slide switches and some push button switches. There's a microphone. The opposite of a speaker is a microphone. It picks up sound and converts it into electricity. And there's even a little motor in there. This is a kind of motor you have inside a cell phone. It vibrates when you turn it on. So it spins inside there with a weight, and it makes it vibrate. It's kind of neat. Okay. I think that pretty much covers all the parts. There was the bag with the proto board in it and the wires, and there's a battery clip in there, and there's also a connector to go to the power supply to run off the battery clip to run it off a 9-volt battery. So that way you can connect up your 9-volt battery and plug it into the power supply to power your circuit. All right, well, thank you for watching this introduction to your electronic kit.